What is the area of the violet triangle? Hence, find the indicated red angle. Trigonometric identities, cosine rule, isosceles triangle properties, area of a triangle, basic arithmetic and algebraic processes are used to solve these questions. Solution to question 1. Label points B, C, D, E, and G. This implies that line BG equals 12 and line DG equals 13. Let angle B be equals to θ. From triangle BDG. Using trigonometric identity, line DG divided by line BG equals tan θ, which equals to 13 divided by 12. We call it equation 1. Also, 1 divided by the square of cosine θ equals the sum of 1 and the square of tan θ. Substitute equation 1. It follows that 1 divided by the square cosine θ equals to 313 divided by 144. This implies that the square of cosine θ equals 144 divided by 313. Take the square root of the equation. Hence, cosine θ equals 12 divided by the square root of 313. We call it equation 2. By Pythagoras' theorem, the square of line BD equals the sum of the square of line DG and the square of line BG. Substitute values. We have that the square of line BD equals the sum of the square of 13 and the square of 12, which equals to 313. Take the square root of the equation. It implies that line BD equals the square root of 313. Consider triangle BCG. Using cosine rule, the square of line CG equals the sum of the square of line BC and the square of line BG minus 2 times the product of line BC and line BG multiplied by cosine θ. Substitute values. We have that the square of line CG equals to the square root of 313 divided by 4. After simplification of values, take the square root of the equation. This implies that line CG equals half the square root of 313. Hence, line BC equals line CG, which equals to half the square root of 313. It signifies that BCG is an isosceles triangle. Angle CBG equals angle BGC, which equals to θ. This implies that angle CGD equals 90 degrees minus θ. Let line DE be equals to x. Line G equal line DG minus line DE, which equals to 13 minus x. Consider triangle CEG. Line G equals 13 minus x, which equals 13 minus 3. That is, the result is 10. Area of triangle CEG equals half the product of length of line CG and length of line EG times sine 90 degrees minus θ, which equals to the value shown on the screen, where sine 90 degrees minus θ is equals to cosine θ. Substitute equation 2 for cosine theta. This implies that sine 90 degrees minus theta equals cosine theta, which equals to 12 divided by the square root of 313. Area of triangle CEG equals half the square root of 313 and 10 times 12 divided by the square root of 313, which equals to 60 square units. Therefore, the area of the violet triangle equals area of triangle CEG, which equals to 60 square units. Solution to question 2. Indicate by labeling angles theta, beta, alpha, and x, where angle x is the required angle. Hence, the sum of theta and 80 degrees equals 180 degrees. It is because the sum of angles in a straight line equals 180 degrees. This implies that theta equals 180 degrees minus 80 degrees, which equals to 100 degrees. Also, theta plus 35 degrees equals the sum of 100 degrees and 35 degrees, which equals to beta. This is because the exterior angle of a triangle equals to the sum of two opposite interior angles. It follows that beta equals 100 degrees plus 35 degrees, which equals 135 degrees. Since the two opposite side lengths of triangle 1 are equal, angle alpha equals angle x. It is because base angles of an isosceles triangle are equal. It follows that beta plus 2 times alpha equals 135 degrees plus 2 times alpha, which equals to 180 degrees. This is because the sum of angles in a triangle equals 180 degrees. Hence, 2 times alpha equals 180 degrees minus 135 degrees, which equals 45 degrees. Thus, alpha equals half of 45 degrees. Since x equals alpha, therefore, the required angle is half of 45 degrees, or 22.5 degrees.